In many cases, we were interested in what happens at different depths in a well. We want to measure the hydraulic head as a function of depth, or we want to obtain samples. And so there are a variety of designs for doing this. And one way of doing this is just to simply create the wells like I described earlier at several different depths. And the way this is done is just basically repeating the process, but the wells are done at different depths, and they're often created fairly close together, so that the wells are then regarded as if they were at the same location in map view, but they just give measurements at different depths. So that's what's shown here. But then the drilling process, the making the hole, can be fairly expensive. So people have developed techniques for creating wells, to creating putting different casings in the same hole. So here's a one well that goes down to the bottom of the hole, and then this is sand right here, and then there's a bentonite seal that's put in, and then more sand and another casing down to this interval. So that's sand and more bentonite and sand and bentonite. So this would all be in a single hole, and there would be three casings that go down to different depths. So that's a different version of a multi-level well. Then there are variations here that are even more exotic, and this is a tube, and these are packers. That's a packer, and so there are 5 packers along this casing, and there are access ports here, and so you send down a little contraption, and it'll open up that hole, that access port, and allow you to get fluids or measure pressure there. And so this is a multi-level well. These things are available commercially, and they're fairly expensive. But if you compare, if you have a deep hole, for example, and you compare the cost of drilling 5 holes to what this would be, these are actually pretty economical. And here we have a couple of other variations on. This is a variation, this is another variation on ways to make multi-level monitoring wells. So once the wells are completed, the next step is to do a well development process. And inevitably, the drilling process will create some fines that have accumulated right along the wall of the well. This can create a skin on the well, so if you're pumping out of the well, that can create head losses, and that would be a problem. And so the development process is designed to remove this fine-grained material. And there are a couple of ways of doing it, but they typically involve generating flow out of the well or through the filter pack and through the formation right around the well at a fairly high rate. And the idea is that that would entrain the particles that are there and remove them. So when you first go to pump the well, you'll generally get some pretty muddy water, and the particles are fairly mobile, and you can get them out fairly easily. But then you need to get higher and higher flow rates to entrain the particles and to do the development process further. So one way of doing that is to use air lifting, where you inject air down into the well and inject it rapidly, and the air forms a bubble, and the bubble rises and pushes all of the water above it out. And so these are some pictures of some air lifting. This is actually done at the lower well field. This is LAR2 right here, and so you can see it's a rather spectacular scene of water coming up out of the well. And so what happens then is if you put a pipe down in the well, say 100 feet, and inject air very rapidly, then that 100 feet of water comes up out of the well in a few seconds, and that's what's causing this geyser-like effect. But then once that's happened, then the pressure has dropped by a lot. Once that water is out of there, the pressure is very low in the well, and water from the formation goes into the well very rapidly. So it's like it's like a giant slug out test. And then as it flows in very rapidly, it entrains particles and removes them from the vicinity of the well. So another approach is to use what's called a surge block. And a surge block is just a cylinder with a seal right here. And that's put down in the casing. And then this is usually done with a drill rig where you put a rod here, piece of steel pipe, and push this down and pull it up with a lot of force. And so you've got the block here, and you push it down, and that pushes water out, and then you pull it back up, and that pulls water in. So this is much like the plunger on a toilet, where you would mechanically push water in and out to try to remove some blockage. So here's another look at a surge block, and this is the surge block being used with a rig, and fairly involved process. Okay, so there's another perspective on this. The development process is used to remove fines. So if the well is created in a sand or in a coarse grain, perhaps even coarser than sand, in a sandy gravel, then what you might do is recover the fines and create a gravel pack that is formed from the naturally occurring material. So that's what's being shown here, where the screen was put in the hole, and the hole was, in this case, the formation was just allowed to collapse around the screen. So there's no filter pack put in here after the screen was put in. The formation was allowed to collapse, and then it was developed, and the particles around here were removed during the development process. And as a result, we have a fairly clean gravel that's formed right around the well. That's acting as the filter pack in this thing. This is called a naturally developed well. And the characteristic is that it doesn't have a filter pack that's applied, because the filter pack is there as part of the formation. So the development process is typically done after the well is completed, but during the life of the well, there are various processes that can clog up the screen and the vicinity of the well. You can have microbes forming that create crusts and biofilms. You can have chemical reactions forming. You could have sediment that forms, or sediment that is accumulating, particularly if it's an injection well. And so often wells, then their screens will clog up through their life, and you'd want to go and redevelop these wells to try to remove these clogs and improve the well performance. So this involves some of the techniques that we just saw, but it also may involve adding chemicals. If you have mineral precipitates that have formed, you may add chemicals like acids, for example, that would dissolve out those precipitates. And then you would, of course, have to flush the well extensively to remove those materials, remove the acids that were used for the redevelopment. This is a well screen with a pretty substantial mineral crust. You can see this is a wire wrap screen, and I think it's fairly easy to imagine that there wouldn't be a whole lot of water flowing through that screen compared to the way it was flowing when it was initially installed. Here's some other examples of some pretty nasty looking screens. So the redevelopment process will hopefully restore those wells and at least improve their ability to produce water to some extent.